Imagine standing on a quiet beach at night, looking up at the sky. Every point of light you see is a star, and around most of those stars, planets are silently orbiting. Now here's the uncomfortable thought. As far as we know, in this vast, almost infinite universe, Earth is the only place where life is confirmed to exist. We've searched Mars, we've dived into the hellish atmosphere of Venus, we've analyzed Titan's orange haze, and we've even listened beneath the frozen crust of Europa. And yet, the question remains unanswered. Is there anyone else out there? If we think about it logically, the idea that we're alone starts to feel strange. There are more stars in the observable universe than grains of sand on all the beaches of Earth combined. Most of those stars host planetary systems. So what are the odds that life sparked only once, here and nowhere else? That exact question pushed humanity to build one of the most important space observatories in history, the Kepler Space Telescope. In 2009, NASA launched Kepler with a very specific mission. It wasn't designed to take pretty pictures. It was built to stare at a small patch of the Milky Way and watch patiently as hundreds of thousands of stars flickered almost imperceptibly. Kepler carried a massive mirror and a 95-megapixel camera, powerful enough to detect changes in a star's brightness smaller than 1/100%. To put that into perspective, if Earth passed in front of the sun's light would dim by less than a blink. Kepler could see that blink. The method Kepler used is called the transit method. When a planet passes in front of its star, it blocks a tiny fraction of the light. That dip in brightness repeats on a regular schedule, like a cosmic heartbeat. Detect enough of these dips, and you can calculate the planet's size, its orbit, and even estimate its temperature. It sounds simple, but in practice, it required extreme precision and patience. Over 9 years, Kepler observed more than 530,000 stars and confirmed 2,662 exoplanets. And with those discoveries, our understanding of the universe completely changed. Before Kepler, we had theories. After Kepler, we had proof. We discovered hot Jupiters, massive gas giants orbiting so close to their stars that their atmospheres are literally being roasted. Some of them complete an entire year in just a few days. We found planets orbiting not one, but 2 stars, like something straight out of science fiction. Imagine living on a world where sunsets come from 2 suns setting at once. Kepler also revealed super-Earths, rocky planets larger than Earth but smaller than Neptune. These worlds might have thicker atmospheres, stronger gravity, and landscapes unlike anything we know. And then there were the truly terrifying ones, lava planets. Worlds so close to their stars that the surface rocks melt into oceans of magma. One side of these planets faces eternal daylight and unbearable heat, while the other side freezes in endless night. Each discovery felt like a message from the universe, telling us just how creative nature can be. But Kepler's greatest achievement wasn't finding extreme worlds. It was identifying planets in the so-called habitable zone, often called the Goldilocks Zone. This is a narrow region around a star where temperatures are just right for liquid water to exist on the surface. Not too hot, not too cold. Being in the habitable zone doesn't guarantee life, but water is a key ingredient for life as we understand it. That's why these planets cause so much excitement. One of the most talked about examples is K2-18b, a planet about 124 light-years away, orbiting a red dwarf star. It's much larger than Earth, closer to a mini-Neptune, but in 2019 scientists detected signs of water vapor in its atmosphere. For the first time, we had evidence of water on a planet located in the habitable zone of another star. Another iconic discovery was Kepler 186f. When it was announced in 2014, it captured the imagination of millions. It's almost the same size as Earth and orbits within its star's habitable zone. Later studies suggested that its rotation axis might be stable, similar to Earth's, which could mean regular seasons and a more stable climate. In the search for life, that's a big deal. Then there's Kepler 1649c, a planet that was almost missed entirely. It was hiding in Kepler's old data until scientists reanalyzed the archives in 2020. This world is only about 6% larger than Earth and receives roughly 75% of the light Earth gets from the sun. That puts it incredibly close to Earth-like conditions. Many scientists consider it one of the best Earth analogs discovered so far. But here's the reality check. Out of Kepler's thousands of confirmed planets, only a small fraction lie in the habitable zone. And even among those, many are tidally locked, meaning one side always faces a star while the other remains in darkness. One hemisphere could be a scorching desert, the other a frozen wasteland. Life in such conditions would be challenging, to say the least. Despite that, astronomers didn't stop. They began searching for something even more ambitious, super-habitable worlds, planets that might actually be better for life than Earth. One promising candidate is Kepler 452b, often nicknamed Earth 2.0. It orbits a star very similar to the Sun and completes a year in about 384 days. However, it's larger and more massive than Earth, meaning gravity would be stronger. Walking there might feel like carrying a heavy backpack all the time. There's also the TRAPPIST-1 system, just 39 light-years away. 7 Earth-sized planets orbit a single red dwarf star, and 3 of them sit in the habitable zone. These planets are packed so closely together that from the surface of one, the others would appear huge in the sky. Some of them could be billions of years older than Earth, giving life much more time to evolve. Another mystery world is Kepler 22b, which might be a true water world. Scientists believe it could be covered by a global ocean hundreds of kilometers deep, with no continents at all. If life exists there, it would likely be completely alien compared to anything we know, possibly bioluminescent organisms thriving in dark, pressurized depths. When scientists analyze Kepler's data statistically, they reach a staggering conclusion. Roughly 1 in 5 Sun-like stars may host an Earth-sized planet in the habitable zone. Considering that about 20% of the Milky Way stars resemble our Sun, this suggests billions of potentially habitable worlds in our galaxy alone. Kepler officially retired in October 2018 after running out of fuel. A month later, Mission Control sent a final command, and the telescope fell silent. But its legacy is anything but silent. Kepler fundamentally changed how we see the universe. It taught us that planets are everywhere, that Earth is not unique in its size or position, and that the conditions for life might be far more common than we ever imagined. Today, the James Webb Space Telescope has taken up the search, analyzing exoplanet atmospheres in unprecedented detail. Future missions will push even further. We may not have the answer yet, but for the first time in human history, the question, "Are we alone?" feels scientifically reachable. Maybe not today, maybe not tomorrow, but one day, when we finally confirm life beyond Earth, we'll look back and realize that Kepler was a moment humanity truly began to understand its place in the universe.